This is a regular octagon, 8 sides. I have the side AB shown here. C is the center of the octagon. If I were to connect any two of these diagonals long ways, you would see that this is where the two sides intersect. Okay. Also, C is a center for a couple of circles that we can draw. Okay. First one that we're going to do is something called a circle based on what we call the circumradius. I'm going to show these two segments here. So we have this segment here and this segment here, and you'll see that this is marked as it has a length of 4.4. Okay. And I can actually draw a circle around this. That circle goes through, it has a center of C, and goes through the point. So CA is the radius of the circle, CB is also the radius. So you can see that this circle neatly passes through each one of the vertices of our regular octagon. Okay? So that's one type of circle that I can draw. There is another type of circle that I can draw. Oops. And I can, if I wanted to draw this one, let's find where it is. I'd want to use a different radius. Now this radius here is the length of from C to the side AB. Now this is the perpendicular. It's not drawn as perpendicular, but this is perpendicular. And this value here is called the apothem, A-P-O-T-H-E-M. And it is the radius that you would use to draw an inscribed circle. So you can see how each point here touches, like it's the midpoint of this segment, it's the midpoint here, it's the midpoint of each of these. Okay? And we call that the apothem. Alright? So those are the two types of circles that we can draw around or inside of a regular polygon. It works for any type of polygon. You could have a hexagon, you could have a 10-sided polygon, you could have a triangle has these. Okay? It just has to be a regular polygon. Now I've taken the liberty of drawing some more triangles. Now each one of these triangles that you can see, like we have triangle, first one we have a triangle CAB, we have CBP, CPO, CON, CNM, so on and so forth. Each one of these triangles is congruent. So that means that you could draw this altitude here and have a 4.1, and that means each one of these sides here is also 4.4. So in order to find the area of this octagon, all I need to do is find the area of this triangle and multiply it by 1, 2, 3, 4, 5, 6, 7, 8. Okay? So my area of a triangle is the formula 1/2 AB. So I do have a formula here. It says 4.1 and 3.4. Okay? So 4.1, that's the height, and 3.4, that's the base. So to find that area, I just use my area formula. So the area of that little triangle, 1/2 base times height, which would be 1/2 of 3.4 times 4.1, which equals 6.97. So that's the area of the triangle. That's this area right here. Okay? To find the area of the whole octagon, let's call that A2, call this A1. That would simply be 8 times A1, which would be 6.97 times 8, which is 55.76. Okay? So to find the area of the polygon, you would have to use this. You can use this formula. You can find the area of a single triangle, and you can multiply it by the total number of triangles that we make. Now that is certainly one method that we can use, but we're also going to look at a different method that works equally as well. The formula that we're going to use is called the apothem formula. So A equals 1/2 AP. Now this big A is the area, the little a is the apothem, okay? P is the perimeter. Now the perimeter here, we have to, if we calculate the perimeter first, that's the number of sides, which is 8, times the side length, which is 3.4. So 8 times 3.4. So 8 times 3.4 is 27.2. Okay? So let's substitute that back into this piece. Okay, so A equals 1/2. Now apothem, remember that's the perpendicular distance. So that'll be 4.1 times 27.2. Okay? So 1/2, times 4.1 times 27.2. So what we get here is A is equal to 55.76, just like we had when we did the previous calculations, 55.76. So you do not have to break it into 8 triangles. You can break it into, you can just use this direct formula. Now this works because you're basically taking the number of sides, the area of one triangle, and multiplying it by 8. But if you think about that, the side that you use to find the side that's 3.4, that occurs 8 times. So that's why we can adjust that to apothem formula. Okay?